Today in this video we are going to discuss one of the excellent trick to find out the hybridization of any molecules. Okay, listen to me carefully. This video will be useful to you. Okay, in the last video I have discussed the concept of hybridization. So I have taken a CH4 molecule as an example and I have explained clearly what is a hybridization. If you didn't watch that video, I'll provide a link in the description box. So please first watch that video, then come back to this. Okay. Now let's get into the topic. Here, hybridization. So how to find the hybridization of any molecule? Here there is a simple trick I'm going to tell you. There is one method to calculate hybridization of any molecule. So first we'll take CH4 as an example. So here carbon and hydrogen, two atoms are there. So here carbon, here it is the central atom is carbon. Now here you just identify the atom, central atom belongs to which group. Here the carbon belongs to fourth group. Now here as it belongs to fourth group, you just put 4 cross marks, 1, 2, 3, 4 cross marks. And how many hydrogens are attached to that carbon? 4 hydrogens. Okay, means 4 bonds. So here one hydrogen, second hydrogen, third hydrogen, fourth hydrogen. Carbon belongs to fourth group, 4 cross marks. And here to each cross mark, whatever the atom attached to this carbon, you just attach that atom to this cross mark. Okay. Now, how many bonds are there? 4. So, 4 bond pair of electrons. That's it. So 4 bond pair of electrons, no lone pairs. No lone pairs. Now, first, before going into this hybridization, how to find the hybridization, I'm going to tell you, I forgot, sorry. I'm going to tell you types of hybridization. So here, if one s orbital and one p orbital overlap, here the type of hybridization is sp hybridization. Here first you make this as a chart. Okay. After that we'll discuss these examples. Now first I want to discuss types of hybridization. Types of hybridization. So here you note this tabular form. So here first one, if one s orbital and one p orbital overlaps, here the type of hybridization is sp hybridization. If at all this is the hybridization, what will be the geometry? So here if one s orbital, one p orbital overlaps, the type of hybridization is sp hybridization and the geometry is linear. This is the linear geometry. For example, A and B are the atoms and linear geometry with a bond angle of 180 degrees. Okay, this is the geometry. If it is an sp hybridization, the geometry is linear. Okay, and the second one, here if one s orbital and 2 p orbitals overlap and the type of hybridization is sp2 hybridization. Here how many hybrid orbitals are there? One s orbital, one p orbital. 2 hybrid orbitals, 1 s orbital, 2 p orbitals, 3 hybrid orbitals here. So here 3 hybrid orbitals means the geometry is trigonal planar. Trigonal planar geometry. Trigonal planar geometry like this. Trigonal planar geometry with a bond angle of 120 degrees. Okay. Now, here third one is if one s orbital and 3 p orbitals are involved, then the hybridization type of, how many hybrid orbitals? 3 plus 1, 4 hybrid orbitals. Type of hybridization is sp3 hybridization, and 4 hybrid orbitals are involved. And as 4 hybrid orbitals are involved, and it is a tetrahedral geometry. Tetrahedral geometry. Here this will be like this. Here will be the central atom, and these are the surrounding atoms, whatever the surrounding. Here also it is the central atom. See here writing. Here these are the atoms with a bond angle of 109 degrees 28 minutes. Okay. If the next hybridization, if one s orbital and 3 p orbitals and plus 1 d orbital, altogether sp3d hybridization, 5 hybrid orbitals. And if it is a 5 hybrid orbitals, if it is sp3d hybridization, and the geometry is here trigonal bipyramidal. Trigonal bipyramidal geometry. Here it is linear, means like this. Okay, linear means like this. This is the, if this point is the central atom, this is the bond angle 180 degrees. And triangle, you know what is a trigonal planar. Here central atom, and around this 3 corners of the triangle there will be 3 atoms. And here tetrahedral geometry means here this will be like this. Here if you assume here this is my forefinger, so this is that atom, and here my thumb, this is another atom, and here this is another atom. These 3 atoms, and here if you are looking at this part, no, this is the upper part. So tetrahedral geometry. Okay, and next trigonal bipyramidal means here the geometry will be, here it is a trigonal 5 atoms, and here it is a central atom bipyramidal. Here it is a you assume this as a this is in the shape of a triangle. So above this triangle there will be one atom, and another below this plane, another atom below this plane. So here trigonal bipyramidal. So here one atom, here 3 atoms, and above one atom, below one atom. Above one atom means above here above the plane of the triangle one, below the plane of the triangle another one. Okay, clear? You just assume this triangle like this. Okay, plane of paper representation is like this, but you assume the triangle like this, like this. Here above this one atom, and below this another atom. Clear? So here it is trigonal bipyramidal geometry. If it is sp3d hybridization, 5 hybrid orbitals, and the type of hybridization is, now what is the bond angle? Here triangle 120 degrees. Okay, triangle means 120 degrees. Above the plane of the triangle, here one atom here, one atom here. So okay, so these are perpendicular to this plane of the triangle. So here 90 degrees. Clear? Okay, so 2 types of bonds are there, bond angles, 2 types of bond angle. First one is 120 degrees and 90 degrees. Okay, clear? And the next one, now the 5th one is 1 s orbital, 3 p orbitals, and 2 d orbitals are involved. Here how many? 3 plus 1 4 plus 2 6. Okay, so 6 hybrid orbitals. So sp3 4 and d2, sp3 d2 and 6 hybrid orbitals. And the geometry is here It is octahedral geometry. And octahedral geometry, and this geometry will be like this. Here will be the central atom. Like this. One atom below the plane and another atom above the plane. Okay. Here it is a it can be octahedral or square bipyramidal also. Okay. Square and above the square. Here similar to the trigonal. This is trigonal bipyramidal geometry shape and it is octahedral. Here how I told you trigonal bipyramidal, here these corner atoms we call as equatorial atoms. Corner atoms of the triangle, the atoms at the three corners of a triangle, we call them as equatorial atoms. These equatorial atoms will be like this, and above the plane, here axial atoms, above an axial atom and below this triangle or below this triangle one atom. So here also, here it is if it is a square planar, if it is a square, above this square one atom, below this square another atom. So it can be called as a square bipyramidal or octahedral geometry. So here the bond angle is 90 degrees. Above the plane also 90 degrees, no? Here below the plane also 90 degrees bond angle, and four corners the bond angle will be 90 degrees. So here, and this is about sp3d2 octahedral geometry. And the next one, sixth one, if one s orbital, 3 p orbitals and 3 d orbitals are involved, we call this as sp3d3 hybridization. 7 hybrid orbitals are involved. 7 hybrid orbitals are involved, and here this is called as, what is the geometry? It is pentagonal bipyramidal. Here, I'll write here. Here, the sixth one, geometry for the sixth one, here it is pentagonal bipyramid. So here pentagonal bipyramidal means how it looks. Here first you write the pentagon. Here it is a central atom. Central atom, 5 atoms at the 5 corners of the pentagon. It is pentagon. Pentagonal bipyramidal, above the plane, below the plane. One atom above the plane of the pentagon. Here one atom below the plane of the pentagon and one atom above the plane of the pentagon. So here it is a pentagonal bipyramidal. Each pentagon, here the bond angle is 72 degrees and here 90 degrees. Similarly, if you observe this three cases, last three cases, I think you got one clear idea. Understood? Here the geometry, if it is SP hybridization, it is linear. Linear means 180 degrees as usually. Trigonal, planar, central atom at the this corner and 3 atoms 120 degrees. And sp3 tetrahedral, this is the geometry. I told you know how the atoms are arranged. And now this is, if you observe last three, trigonal bipyramidal, just it is a, you assume this as a triangle, and triangle, an atom, triangle means 120 degrees. No need to by heart anything, okay? Triangle means 120 degrees. Above the triangle, here perpendicular, 90 degrees. Here below the plane, 90 degrees. 120, 90. Clear? Here also, if it is, you assume it's a square bipyramidal or octahedral geometry. If it is 6, if it is 5, you assume triangle, 3, one above the triangle, one below the triangle. Okay, 5. 4 means it is a tetrahedral like this. Okay, Trigonal planar means triangle. Okay. And octahedral, here it is a square planar, one above the plane, one below the plane. Square means 90 degrees bond angle, and above the plane means it is perpendicular to square planar, 90 degrees again, 90 degrees again. Okay, octahedral or square bipyramidal also you can write there. And seventh, if the hybrid orbitals are 7, then it is 7 means the geometry is 7 means 5 plus 2. Pentagonal, pentagon, in the pentagon 5 atoms occupy including central atom, and another atom here with the examples we'll discuss how to find out the hybridization and how to find out the geometries and shapes also. Geometry is different from shape. Okay. Now here the pentagon, in the pentagon 5 atoms occupy the corners of the pentagon, one above the plane and another atom below the plane, 90 degrees. Okay, and remaining 72. This is the types of hybridization. First, this is about the types of hybridization. In the last video, here we discussed what is the concept of hybridization, and here in this video it is the types of hybridization with geometries and bond angles. Okay. In the next video we'll discuss how to find out the hybridization. Okay. Bye.